Cool, cool. Well, I think we are live. Are we showing up yet on the YouTube, dude?
Um,
Not yet.
not yet. Yep, just started.
Cool,
Sweet.
cool.
And then
If you guys are
Twitch
there,
is also
let us know.
cool.
Start chatting away so we know you're there and that you can see us.
Yes.
Dude, no one wants to chat away, dude. Oh, we got.
Uh,
There we go. We got.
hey,
Hey!
hello, Sheldon Rayleigh. good to good to have you today. Oh, Kelsey's on the YouTube.
Yeah.
Sweet.
Hold on.
Hello, how are you? I'm doing well. How about yourself? And how are you doing, Kip?
Dude, I'm doing pretty good. I just.
Awesome.
I just gotta log in here to my chat
Sweet.
because apparently it logged me out. So that's rude. So
That was super rude.
oh, that's why. Hold on. Should we get started?
Yeah, let's do it.
All right. Well, welcome everyone to um our live stream tonight. Tonight we're going to be learning about light's spectrum. So if you guys remember, as of last week, we learned about Maxwell, and he came up with these ideas for, this um or this electromagnetic wave, right? But the thing is the wave he came up with didn't actually show. I mean, the light, when he created this wave and came up with it, he didn't actually
Uh-huh.
see this light, but he claimed it was light, right? But it wasn't there, it wasn't visible, which kind of led to this whole discovery of how light isn't just what we are able to see, right? But rather it's a much
So
broader thing than
you're
just.
saying that there's more out there than just the colors that we see?
That's what I'm saying, Jaden.
Dude, no way, I don't believe it. I need to see it to believe it.
You can't. That's the whole point, dude.
Okay, I'll believe the math. Okay, that's good. Yeah, so the main thing from last time was this electromagnetic wave that Maxwell kind of stumbled upon and found that it was actually an equation for light. This electromagnetic wave was for light.
Yeah. So, but before we get too far along,
Uh-huh.
I want to talk to you guys. Me and Jen are going to talk to you guys about some donations. Okay?
Okay.
So, if you're on Twitch, there's a donation button that you can simply just click and you can make a donation. Okay? Or if you're on YouTube, in the description there's a link for donations as well. And if you donate $5, you get to
Uh-huh.
choose either one of these awesome stickers that was made by Shaylee. Or if you donate $25, you get a sticker and a t-shirt. So just a little bit of an incentive to kind of help you guys out with wanting to donate. And again, that description on YouTube has a link, and also there is just a button to push on Twitch. And then with that, if you guys, aren't feeling super charitable and we're not worth $5 or $25 or anything in between, if you guys have any donation, make any donation, you can either choose one of these 3 textures for this week, and where your high score is over there, it'll not sure where, somewhere, it will wrap your name and your score in that texture. Okay. Or you can just simply choose
cool.
any color that you want. And that is, if you watch through the Shaylee wants number 1. Okay. Shaylee, you can have number 1 because you donated last week though. So your name has been changed to green and gray because that's what you asked for this week.
Whoa. Pretty cool.
Apparently Mantis Shrimp can see.
They can see a larger range of the light spectrum than humans. Cool.
Cool. So, alrighty, now that we've kind of gone over our, self-promotion there for a few minutes. Also, don't forget to like and subscribe if you haven't, because if you do, it helps you get a higher score. And right now, Kelsey is definitely leading the charge by a lot. So you guys could definitely use some help by getting some multipliers going. Just saying. Sweet. And with that, we have our first question of the night.
Right. It is, what is radiation? There is a lot of confusion with radiation.
Jen, real quick, I just saw one question pop up that says, how do I donate? And so in the description on the YouTube video, there is a link that says donations, or please donate here, and then there's a link, and then you just click on that. So that's how you do that. You do need a PayPal account right now. If enough people donate, then we're able to use just credit cards and debit cards. But anyways, okay, so what is radiation? We want to hear your guys' thoughts on this, and Jaden was explaining something, so continue.
Yeah, I was just, right, there's a lot of confusion with radiation. We want to know what you think radiation is. So just type it out in the comment, and we will kind of talk a little bit more about that after we get some comments. But while you are commenting, Kip and I are going to talk about different like radiation things that are on like TV,
like the Hulk,
or like superheroes. Yeah, like the Hulk. And if that would actually be possible or not, or if we could get like the multiple headed animals, or I don't know. So, what do you think about that, Kip? What do you think about the Hulk? Well, let's start there.
Well, I'm pretty sure he's exposed to gamma radiation, if I'm not mistaken.
Yeah.
And I think that would just kill you. That's my response.
Yeah. Yeah. As much gamma radiation that he was exposed to. Yeah, I agree with you. But we're getting some comments in. Very small wavelengths that disrupt your atoms because of how small they are. Radiation can be dangerous because of what Sheld says.
Chernobyl.
Energy traveling through something. A 25 kill streak.
From COD. Yeah.
Electrons jumping around. Yeah, some of those answers are really good. So kind of like the definition is an emission of energy through an electromagnetic wave or subatomic particle. Uh, especially, so you'll see people talk about radiation, especially in high energy waves or particles that change like the ionization of atoms and particles and molecules.
Yeah.
So keep those in mind. High energy and ionization.
But
But all electromagnetic waves are forms of radiation.
yeah. Um cool. So, let's get going. So, here is a quick, view of the spectrum of light, right? So,
Okay.
depending on its wavelength and or frequency, you can have different types of light, and this is just kind of a quick overview of that, right? So, we've
Right.
got gamma rays, X-rays, ultraviolet, then we've got the
Okay.
visual, optical light, whatever. And we got infrared and we got microwave and radio waves. So we're going to go through all of those tonight quickly and help you guys kind of understand really what radiation actually is and maybe to learn to not be so scared of it. And learn a little bit more about the light that our eyes can perceive. So, we've got these equations here, but first, before we do that, I'm going to show you guys a video. Ready? Here we go. So in this video, you have this yellow ball that represents an electron, right? Now this electron is moving up and down, and that purple line that has now become squiggly is the electric field. So as it moves up and it moves down. But that electric
Okay.
field is also, the wave is moving through time. So I'm going to show this one again, and I'm going to have you guys look at a few things um, as I go through this. The first thing I want you to look at is there's a green cube at the beginning. Now that's the velocity at which this wave is traveling at. Okay? The next thing I want you to look at is from one of the peaks to the next peak. That's going to be the wavelength. And then
Okay.
lastly, we can see the period if you watch and focus on one of those green balls and watch what happens or watch how long it takes from one peak to the next peak to travel through one of those green balls. So, here we go again.
Okay.
So the cube starts moving, right? That's the velocity of the wave. And then we can watch, so it hit the bottom one, and now it hit the bottom one again, right? So that would be one period. It's how long it takes for it to
Cool.
complete one cycle. And then the wavelength is from one of those peaks to another one of those peaks. All right. So now I'm going to show you another one. And this one, we're going to change the wavelength and make the wavelength shorter. And so here we go again. Now the wavelength's shorter. And what you'll notice is it also means that it's kind of oscillating faster, right? Which is its frequency. So if you have a shorter wavelength, then it also has a higher frequency. Okay? So those two were traveling at the same speed. I'm going to show you a third one, and during this third one, it's going to be traveling faster but have the same wavelength as the first one. You guys ready for this?
Yeah.
Whoa, 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 whoa. So this one's going
Whoa.
really fast, right?
Whoa, 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 whoa.
You like that, dude?
Okay.
Um,
Yeah, I like that.
so as we're watching this thing go here, what you'll notice is it's hard to notice in this video, but the wavelength is actually the same as the first one, right? So the wavelength
Okay.
hasn't changed, but the velocity has, which has also increased its frequency. So two
Right.
different things can change, its frequency, And just to kind of iterate this a little more, I'm going to superimpose all three on top of each other and watch them again. So, if you were to take the first video and the second video and measure their wavelengths, they would have the exact same. So peak to peak would be the exact same, or trough to trough would be the exact same length between the two. But the frequency of the two would actually be different. Okay? And so now that I've showed you guys all those videos, let's get back to them slides. And thank you for saying that the animations look so good. So that brings us, yeah.
I just want to point out how awesome and brilliantly cool you are, because those animations, you use these equations that we're looking at to make those. I just want to point that out and like kind of hype you up, because that's really cool. You're able to program those animations. It's just cool. Okay. Anyway,
well, thanks. I mean, but that's right. Like, this is where physics meets, you know, math, right? I'm able to simulate something that's a real world thing using the math equations. So you can predict these things through that. So, anyways, we've got these lovely list of equations, and or you know, all these things. And so we talked about wavelength. We talked about frequency. Jaden, we got this weird looking K, which is a wave number. So what does that kind of mean?
So with sines and cosines and circles, every 2 pi is kind of like a revolution of a circle. So that's helpful in that. That's what the 2 pi means. And then you see that it's divided by the wave length. So every time it goes to a complete like cycle, you divide it by the wavelength. That's how many wave number you have.
Yeah.
That's what that's
good.
Looking at.
And so if we go to the right-hand side, right, this equation on the right-hand side where it says E equals E naught sine of this K x minus WT, right? If we got rid of that WT, the X represents a distance, right? So that K is related to the wavelength, which is also a distance. So you have these two distances, and so if you got rid of the W and T, you would get what you normally would see on a graph of like a sine wave, right? Just like this up and down sine wave graph, where you would have a set wavelength. But the thing is, Jaden, this wave is not just standing still, right? It's moving through time, which is why you have this weird W and T associated with it.
Just so everyone knows, that weird W is an omega, just so Kip can start calling it omega.
Yeah. Which is a Greek letter. So when you do lots of math and physics, you use lots of Greek letters. Pi is a Greek letter, but most people already know pi because they just do. But omega is the angular frequency, which relates how quickly this thing's going to loop through one of its cycles. And so you have these two different things. So the frequency, what it essentially comes down to is how many cycles it's going to go through per second. And we're not going to dive too much more into this because it's not that important. But the last important thing is that the speed of light, which is c, is equal to the frequency times the wavelength. And in a more generic form, it's just the velocity is equal to the frequency times the wavelength. But with this,
that's the velocity of the wave.
Yes, exactly. But for all of you out there that are just, you know, I mean, in air, the speed of light just has a set speed of light, right? So you can figure out what the frequency is or the wavelength just purely based on what that speed is. And that equation is going to come in handy next week. So that C equals F. Oh, and that weird sideways T thing is a lambda, and we use that for wavelength. So it's C equals F lambda. Okay,
cool.
So we got our first challenge question of the night. You guys ready to answer some questions? Here we go.
Let's just quickly talk about how the rolling the dice works.
Go for it.
So the question is the bad guy. We roll two 20-sided dice. If it's an easy question, we take the max number. If it's a hard question, then we'll take the min. Then the good guy, that's being us and Light and everybody watching, we roll two 20-sided dice. If more people get the answer correct, we take the max to subtract from the bad guy roll. And if more people get it wrong, then we take the minimum of the dice roll and subtract that. And then for every correct answer, we add one to the dice. Okay.
Cool.
Now,
so we got 2 answers so far. Please keep them coming. We would appreciate some more coming through.
Yeah, we got 2 answers. Sweet. What wavelength range is visible light? Greater than 700 nanometers, between 400 and 700 nanometers, or less than 400 nanometers? We got 3 Bs.
Yeah, 3 Bs. Come on, guys. I know there's a lot more of you out there watching. Don't be scared. Just answer anything. Remember,
another B. 4 Bs.
What? Yeah.
4 Bs.
Well, does that count? Oh, we got 5. We're up to 5 Bs.
Wait. Shaylee is on both Twitch and.
Anyways, keep them coming. I know that you guys are all out there. Remember, there's nothing, you don't get nothing docked or anything, but you do get points towards your high score if you answer questions. So I highly recommend you do that.
Okay, should we go through?
Yep.
So good job, everybody. The answer is B. You guys are so smart. We
didn't even teach you
that
that
was
yet.
An easy question. Yeah, we didn't even teach
I'm
that.
rolling. Ooh.
Okay, roll.
Okay, so their max was 9. Okay. So now let's roll us. And our max is 10, and most people got it right, so we didn't lose any health on that one. So we are good to go.
Get some red in that health bar, you know what I'm saying?
I know what you're saying, dude.
No, it's good. Cool. So yeah, the answer is B. Good job, everyone. Woo!
All right, so now we're going to kind of plow through these pretty fast because we're, taking a little long, but that's chill. But here we go. So guys, we're going to now learn about the whole spectrum of light in a few minutes. All right. So we've got radio waves. All right. And to keep you guys understanding kind of like what these things are, we've got power levels associated with them, because me and Jaden like things like Dragon Ball Z. And so, we associate power levels with things.
9,000.
And so, to start off, it's got a frequency of 50 megahertz to 1,000 megahertz. That means that it will go through, a cycle every second. It'll go through 50 million cycles. So that's a lot of cycles already. But it's got a wavelength of 1 kilometer to 1 centimeter. Okay. So these wavelengths are really big, right, Jane?
Yeah.
Yeah.
Why do you think that's beneficial for like radios and cell phones? Because you have those on the slide where they're used in cell phones and radios. Why is having that long wavelength good for those?
Yeah, so we have an answer in the chat that says they go a long distance, right? Because they have this long wavelength, they can actually go around things pretty easily.
Cool.
Um,
Yeah,
and
they don't destroy things on the way. Cool.
yeah, so they have the
Yeah,
ability to go
yeah,
around things really easily. So that makes them very useful for things like car radios or cell phones or internet
yeah.
because they're not easily blocked, right? But it's the same reason why if you're in a cement building, you don't have any internet or cell phone service. But people talk about being worried about things like 5G, but this power level is only at 124, and like you'll
Right.
see where we need to start worrying about radiation.
Okay, cool. So that leads us to
Like an
microwaves.
oven?
And yeah, like the microwave oven. Yeah. We see the power level. We got is that 6 zeros on there. That seems kind of a lot of power, Kip. Should we be scared?
I don't think so, because it's still below visible light, and we're always surrounded by visible light, right? And it
Okay.
still doesn't, visible light doesn't hurt us.
Okay. Cool. Uh, so you will notice that part of this wavelength goes into the radio wave length. Um, and that is because it's kind of like a subclass of radio waves. It's just a little bit shorter wavelengths, but it is used for a lot of the same things as the radio waves. We have point-to-point telecommunications, like cell phones, still with radios. But the big difference is we use specifically in a microwave ovens to heat up our food.
Yeah.
And that is because the water molecules in foods have the same, is it the same
Yeah.
frequency or,
So the water
yeah, same
molecules, yeah,
frequency
want to vibrate at the same frequency,
at that rate? Yeah.
and so it creates a friction. It's like, and so that heats heats things up. So if you had something with no water in it and put it in a microwave, it probably wouldn't get very hot.
Cool.
Cool. And also, real quick, back to radio waves. A radio
Yeah.
antenna works the same way, so it has to have a similar frequency to the frequency of the radio. And when you see the radio tuner and all those numbers on it, that's actually the
Uh,
frequency of the radio wave.
so when you're switching channels on your car radio, you're actually changing frequencies to, I guess, interpret the frequencies of radio waves hitting
Exactly.
your antenna. That is really cool.
Okay, Jane, so now we're on to infrared, which for all you grammar nerds out there means before red, I think.
Yeah, probably like some like Latin root is before
Yeah.
red. Yeah. So now we have even more zeros, Kip. Uh, do we need to be scared?
Nope. It might give you a little burn if it's too hot, but
Okay. So you might not want to touch certain things because of infrared, but it's not gonna like bombard us.
yeah.
And okay, cool. Uh, cool things to notice in this is night vision equipment. Uh, with infrared, you can see body heats through the night, and with the night vision equipment, you'll be able to see that. Another thing is meteorology. We can send images from satellites, and we can interpret these images using infrared light to see what kind of storm is approaching, uh, kind of plan our day around hurricanes. I almost said hurricane like Utah. Oh, uh, yeah, that's
Yeah.
kind of the uses of the infrared light, and it's kind of cool stuff.
Cool, cool. Which leads us, Jaden, to visible light. Okay.
We have Roy G. Biv on here. What does that mean?
I don't know. What does that mean, Jaden?
I think that's one of the colors of our rainbow: red, orange, yellow, green, blue, indigo, violet.
Nice, dude. So,
Dude, look at this power level.
dude, that's pretty high. Should we be worried?
Um, no, like you said before, we are always exposed to this. This is what we're seeing when we open our eyes, right? This is all around us. But something really cool. This is our power level of our character, Light. So just kind of be aware of that. It's pretty cool. Pretty cool guy.
Yeah. And so the question, so we're kind of biased towards visible light, right? We think that visible light is something special or unique. It's different than radio waves, right? It's different than microwaves. It's different than infrared. It's different from all these radiations that we've talked about so far. But it's actually not. I mean, it has a higher power associated with it. But the thing
Uh,
is that our eyes are just tuned to be able to pick up. And if you look at the wavelength, it's a very small wavelength, right? Or chunk of wavelengths that our eyes are able to pick up. And so if
right.
our eyes were different, we could see radio waves and we'd create a scale associated with that as well. We don't. We see visible light, and so our brain has come up with this scale, right, to interpret all these different wavelengths of visible light. So, RGB stands for red, green, blue. Okay, so which leads us
Cool.
to this question.
So
Oh, Jin, did you want to say more before I ask the question?
yeah, just yeah, you're saying that our brain is interpreting all this stuff. Um, that's I don't know. Just think about that. That's kind of cool, right? You're just our eyes are getting the sensing these wavelengths, and our brain interprets so we can actually see. I don't know.
No, no, it's really crazy. So that brings us to the question, right, Jin? What is color? What is it?
Okay, and this is another one of our thought-provoking questions that we want to have comments about it. Uh, because honestly, I don't really even I don't have a good answer for this, right? Just like I know that it's electromagnetic waves at a certain wavelength and frequency, but yeah, like why do we see? I don't
Yeah.
know.
What is it?
It's
So we've got color is reflected light. Okay, that's good. What else we got, guys? Come on.
yeah,
Comment away. Think about it. Think really hard. I want you guys to break your own brains. Beautiful light. Okay. That's good. But like stop and think about it for a moment, right? Like you're constantly perceiving all these colors. What is it?
yeah,
Light reflecting that's not absorbed. Okay. But what is it?
yeah.
Like
I like all
what
of it.
is that light? Why are we seeing that and not
Yeah. Like imagine if humans were able to see the infrared, right? Would we interpret that and make colors out of that, right? Or well, I don't
yeah,
know. I
yeah,
don't.
no, exactly.
Or if we were on the other side, ultraviolet.
Yeah.
Yeah, maybe your purple is different than.
Yeah.
Yeah, I
You'll
don't know.
never know. So, okay, we got light moving at different frequencies, and these are all right answers that you guys are saying.
Yeah.
Um,
Maybe color is how nature communicates.
Yeah.
Yeah.
But a way the brain interprets light that our environment gives us. Okay, so these are all really good answers. To quickly give like somewhat of an idea behind this is that our eyes have different sensors in them, these rods and cones that you guys keep talking about, right? And they receive certain information from the world around you, just like a camera does or other sensors do. And then your brain actually interprets those sensors and says, okay, this has these groups of wavelengths, so I'm going to associate it with this color. These ones have this group of wavelengths, so I'm going to associate it with this color. Which leads us to our next challenge.
Dun dun dun.
What makes white light? So you have your primary colors in, in painting pigments.
Yeah.
But what are the primary colors for light? Because you've got the three primary colors of light equal white. So,
Uh, you were right. Angie says red, green, blue.
yeah,
What letter is associated with
red,
red,
green,
green,
blue.
and blue?
Okay, we got a C.
Got a C.
We'll help Angie out. That's also C. So we have two C's. We got an F.
F. None of the above.
And while we're talking about this, just so we know how these colors were discovered, remember that guy Maxwell? He created a wheel that he
Yeah.
would spin, right? And he would put in different colors and he'd go around asking people after he'd spin it. So our eye would add all the colors together. He'd say, what color do you see? What color do you see? Trying to get to this white. And he eventually
Okay.
found it. And then from there, he was able to take that information and make this picture that's in the background. And that is actually the first ever color photo taken. And it was made by a physicist. So, who says that physicists can't be artists?
Yeah.
Okay, so we got stuff all over the place. For this one, let's tally them up.
Yeah. So we got F, G. I'm still overwhelmed. C,
We got two C's.
C. Got a G.
Okay.
A, G.
So we got G. Anyways, I think we only have 3 right answers, and I think we have more than that. So for the first time, we have more wrong answers than right.
Yeah, we're gonna take the
We're going to
minimum.
take the minimum.
And we have 1,
So
2
should we tell them what the right
right
answer?
answers.
We got 3, I think. Yeah.
3. Okay. Yeah. The answer is
C.
C.
Cool. So let's roll them dice. Ready? Here's the bad guy roll. Do-do-do. Ooh, they almost got 20. Oh, they have 18. Ooh. I mean, is this an easy question or a hard question, Jade?
Let's say easy.
Yeah, so they have an 18. Okay. And ooh, doubles, dude. So 15. Hey, they had 3 right, so we still didn't lose anything. That was lucky for you guys. Good job.
Yeah, that was fortunate. Cool.
Okay, so just really quick to go over this, red, blue, green are the colors that every other color that we see our eye interprets to make all the other colors, okay? So scientists know this, and that's why, like, comments so far have said RGB lighting is a thing. Red, blue, green lighting
Yeah.
is a thing. Almost all screens are made up of a red, green, and blue pixel, and if you change all those, then our eyes can perceive all the different colors based on that.
Right.
So, anyways, quick tidbit there.
That's cool.
Ooh, Jaden, this looks painful, and look at that power level.
Ouch. Uh, how many zeros is that? Is that? Are we at 12?
I think so.
Yeah, we'll say 12 or something. Ah,
Yeah.
okay. Yeah. So our frequency is 300 terahertz to 30 petahertz. That's what the P stands for.
It doesn't stand for
Kip
Pika.
and I had to look that up because we didn't even know what that was. And we see our frequency is increasing, our wavelength is decreasing. So our ultraviolet is when we start getting sunburns and the start of ionizing radiation. So if you remember at the beginning, we talked about high energy and ionizing radiation. That's what we need to worry about with radiation. It's when these wavelengths can start penetrating your skin and start kicking away electrons. That's what ionization is. Uh, and that's when you get sunburns. Uh, ouch.
Yeah.
That guy is having a really good day or bad at night. I don't know. He's at a pool. Maybe he's having a good day.
Yeah. And so with that, right, this is, if you notice, this is 12 more zeros than where we started with radio waves. So you really have nothing to worry about with radio waves. If this is just the start of where you need to get worried, right? This is where you start to get skin cancer and all that kind of stuff. But it doesn't even have enough energy to penetrate through the skin still, right?
Right. That's good.
So that's good. So our skin protects it, and then also our atmosphere blocks the most dangerous UV rays as well, which is pretty nice. So then we move on to.
That's why we need to protect our ozone.
Yeah, don't let our ozone get destroyed, or else we would literally just fry. We would just.
Yeah.
Go away.
That'd be bad.
Which leads us to X-rays, Jaden. So X-rays have even a higher power level. So now we're up to 10 to the 13, or yeah, we've got like 13 zeros, I believe now, or 15, sorry, 15 zeros. Maybe 14 zeros, somewhere in there.
Just count the zeros.
And our wavelengths are getting really small. Right now they go to a picometer, which is 10 to the negative 12.
Wow.
And so from there, it actually is small enough. These wavelengths are small enough they can actually penetrate through your skin. And they have to hit something really dense, right? Such as bone to be blocked. And that's how an X-ray works. So that's how you get like an X-ray picture.
Maybe that's why we can see Homer's brain, is because it's so dense.
Maybe, dude.
I don't know.
I wouldn't put it past
So another cool thing is black holes will send out X-rays, and that is how some astrophysicists study black holes with the X-rays. And if you've ever broken a bone, you know that you've been given a big vest, or if you've been to the dentist to get X-rays on your mouth, they give you a big heavy vest, and that's so the X-rays don't penetrate where they don't want them to penetrate.
Exactly. So because these are starting to get dangerous, right? They have a lot of energy associated with them, and they can cause damage to DNA structures inside of you, which can lead to things like cancer. but only if you're exposed to a lot of them, right? Like think about how long you have to be
Right.
on the sun before you get a sunburn. You have to have prolonged exposure to these things. So X-rays every now and again aren't bad, but that's why they don't just leave you, getting shot by X-rays all day long, and they try to limit the amount they give you. All right,
Right.
Jen, which leads us to our very last light on the
Part of
light spectrum, which are
yeah, and this
gamma
is
rays. And these things are things you
and
don't want to mess with.
yeah, so this gamma rays, as you can see, have the highest power level. Uh, they have a really high energy and high frequency. They can penetrate all the way through you. So sometimes maybe if you got shot with like a gamma ray, it might just go through you and not change anything in your body. But if you're blasted with these over and over and over, that's when it's gonna
That's
start
when you
changing
turn
your
into the
body.
Hulk.
Yeah. Yeah. But this is a cool like thing we found out is gamma rays are used to sterilize seeds. Uh, I don't know how they do it exactly, but as just a cool thing. And also used in PET scans. Uh, that was a positronal tomography. I can't remember exactly. But those are just for imaging throughout your body. Find out
Jane, how long
what
have I been
kind of.
tiny for? Fixed it.
I didn't notice.
Okay, well, yeah. So
And
there we
gamma
go.
rays are also used to study space and galaxy, just kind of like X-rays.
But that's what we've got as far as our electromagnetic spectrum goes, or radiation, right? So we've
Uh,
got one last challenge for you guys, which is,
and before we go into
oh,
that challenge,
yeah, go
let's
for
just
it.
kind of emphasize for this class, we are going to be dealing with the visible light because we want to get an image through our camera and we don't have cool infrared camera and we don't have a cool ultraviolet camera. We just are sticking with a normal everyday camera. And that's what we care about in this class.
There you go. So thanks for that. Okay. So, is all radiation bad for you? And this one was what we spent the whole class on, so please answer this right, or else we'll feel like we have completely failed you.
Like we're getting some B's
Got
in the chat.
yeah, we got two
Very good.
B's, three B's.
Dude, Kip, what kind of radiation do you want to be exposed to?
Dude, all of them at once.
All of them at once. Nice.
Dude, we're getting a lot of B's.
Okay. Yay.
Yay!
Good job, everyone.
Oh, we got more B's. So,
True.
all right. Well, guys, that concludes our lesson for tonight.
Wait, are we gonna roll the dice?
Dude, everyone got it right, so no. That's
Oh
what
yeah,
the rules
true.
say. But we can't add
We did
health
make
because
that.
we're at 100% health. So,
Yeah, true, true.
GG. Jake, there is no C, buddy.
Roll
Alrighty.
the dice. Hey.
So remember, guys, you can go ahead and donate if you guys want to get one of these stickers. Donations in the link below. Oh,
GG.
I think, Jared, you already answered, so sorry, I'm not taking your second answer.
Yes. Yeah.
But I'll roll the dice for you just for the heck. There we go. We got
Kind of a cool dice roller. Oh, that would have been easy to beat
I know.
anyways. You more than 6 of you got it right.
Yep. Don't forget to donate. If you can't afford $5, donate anything, and you can pick one of these cool textures to wrap your name with. So, anyways,
Like and subscribe if you
yeah.
haven't.
Don't forget to like this
And
video, guys, because if you don't, then you don't get a good multiplier.
true.
Thank you, Angie. We appreciate that. Um,
Yes.
anyways, we haven't gotten any new subscribers tonight, so that's kind of sad. Maybe we have. I don't know, actually. But their privacy settings might be telling us that, who knows. But yeah. Well, any last minute questions that we can answer for you, or we will be done?
I'm just trying not to be in last place. Good job.
Good job.
Cool. Well, thank you all for joining us tonight. And yeah, we'll see you next week. Next week, we are going to start.
We're actually going to start things that are cool.
We're going to start going through a camera.
Yeah, that has been the backstory. So next week, we'll actually learn how. We'll start learning how a lens works, which is pretty cool. So
Awesome.
there you go. See you next week, and goodbye.